Hello everyone. In this video, we're going to learn about a new, very important and powerful module for data analytics. The name of this module is Pandas, and it's been very essential in the success of many projects in data analytics. The reason is this module comes with so many different functions that are just perfect for manipulating, reading, and analyzing data. So let's get to it. So the first thing we will do, we will import pandas. So like NumPy, the way normally this importation is done is by naming it as PD. So like NumPy was NP in the data science community, pandas is known as PD. So always we import as PD. So once we go ahead and we do this, now two major things about this module is that they have two types of data structure you can be working with. If your data has only one column, normally you want to work with series. If it has more than one column, you work with data frame basically. So let's get to know series and then we'll get to know data frame. The reason we will go with series first is basically because data frame is actually a collection of series, as we will see in the remainder of this video. So series, as I said, is a one-dimensional array that sort of like store one column of data. And in the series, what you will have is just values and indexes. Like just imagine one column in Excel sheet, so you have like indexes and those values, and that's it. Those are the only things that you will have access when you work with series. The way you go about creating it, if you pass a list to the function pd.series, it creates a series for you basically. So here we go. So this is our series. So this is my 0, 1, 2, 3. These are my indexes and these are my values. I could be accessing these values differently. So for example, I could say my series 0, which I'm passing the index. And then it gives me 1. My series 1, it gives me apple. And then so on and so forth. So we have these indexes because we didn't specify what these indices were. These were created as the default for us, but we could specify them. So here I have created a new list and I'm giving them the indices, and name. So this is the name, this is the major, and this is GPA. So once I run this, now instead of 0, 1, 2, now I have the name of the indexes that I want to be using for this series. So I could be accessing them with these new indices from now on. So I could be saying sname and get an error. The reason that I'm getting an error is because this name in single quotation is the index. Name is the way Python is debugging, the Python is compiling this, it's sort of seeing name as a variable, and name is not a variable that it knows and says it's not defined. So the way you want to go about this is say name in single quotation. So once you do that, now it recognizes that index and it brings Emily for us. So another way you could do it, which is very powerful, that Python and pandas allow you to do it, is say s.name. Once you say dot, it says the property of this series, there is something called name, and then it recognizes and it works for you. You could have also done by sort of like going with the default as the indices, and it also works for you. So if you don't, if you also work with those 0, 1, 2, 3, it also works for you. You could also go with iloc, which is the index location. It also works for you. You could also work with .loc, which is the location based on the specified indices. and it also works for you. So there are so many different ways that you could access a series values, and that's one of the power of pandas data structures. So next things we will look at is data frame. So data frame is basically a lot of times what you will be using whenever you're working with data analytics in Python. Data frames are sort of like the foundation of all of our analysis, program analysis from now on. And basically it is data structure that, you know, wherever your data is an SQL, an Excel, CSV file, XML, you know, all of those different data sources that you have, it can be read and, you know, brought to your fingertip to be using with other pandas functions to be able to do your analysis. So here's the data frame. Let's get introduced to it. Basically, data frame, as I said, is a collection of series. So this is one list, another list. I'm calling these lists by their name. I'm saying these are name, these are date, these are shares, and these are prices. So basically, I have collections of you know, stock prices. So once I run this, now I have not only I have indexes, but I also have columns. This is the type of data sets that we know of, like, you know, columns and rows, and also columns and rows, and also you know, the data objects and attributes. So this is the typical data set that we know of, and that's what pandas data frame also based upon. So one thing you could be doing, there are a couple of things that sort of will go here. One thing you could be doing is you can create a new column very easily and sort of like assign a default value to them. You say df owner in brackets, and it sort of creates a whole new column for you in your data frame, and you have that owner, and the default value is unknown. You could change your indices. So if we have 0, 1, 2, you could change them into the words 0, 1, 2 or 1, 2, 3. So once I run this, now I have changed my indices. Or you could change your index. Instead of 1, 2, 3, you could say, okay, you know what? I want to change my index to this column. So once you run this, you will not get what you were looking for. So you were expecting this to actually sort of like get rid of this column or this index and sort of like put this over there. What's happening there? Let's run this also and sort of like think about what could be going on here. So why am I seeing two different things? I'm running the same functions, but I'm seeing two different things. Think about this for a minute before continuing to watch. So what's happening here is that sometimes some of the functions will, in pandas, will sort of like output a whole data frame. So when you say df.setIndex, it sort of inputs that data frame and changes the data frame index and outputs a whole new data frame that has the index, the name column as the index. But here we don't do anything to it. It's just like it does it and it's just gone because we don't equate it to anything. We don't assign it to anything. And that's why when you say df, it basically brings the unchanged data frame back. But here, because it's the last line that is being run, it shows us, Jupyter Notebook shows us what this function is outputting. That's basically what's happening here. So even though this looks like that this has been done, but if I run df again, it hasn't been done yet. And the reason is just why, because I explained. So to remedy that, there are two ways you can go about this. You can equate the output of this function to data frame. So whatever comes out of it, put it where it is, so now you will have a new one. Or you could use a property of this function, which is called inPlace equals true. The default of inPlace is false, which means you don't want it to change the data frame that this function is working on. But if you say the inPlace is true, it basically says, I don't want you to output a new data frame, I want to change this data frame. And once you run this, now you have what you were looking for. Accessing a data frame, exactly like accessing series, is it has a lot of different ways to go about this. It's very versatile data structure. So you could basically say dot each column, dot date, dot price, and it will bring all of that column with the indices that you have specified. So it's a series right now. Or you could be saying bracket, colon, bracket, quotation date. And that is going to be bringing the same thing. It's just different way of doing the same thing. And then you could also be accessing different rows by iLock or index location 0, and it works for you. Or you could be using the assign indices, which is going to bring the same value, the same values for us. Or you could be sort of like treat this as a matrix by the iLock 1 and 1. Or you could be sort of going by series and series. So you say, okay, I want all of the rows for IBM, and it gives you a series, and then go from there. In that series, I want only the shares, and it will give you the same answer. Or you could do the same thing, sort of like, again, treat this as a matrix, but instead of using the indices or the default indices, use the index and the column assign names for accessing what you were going to access. So these are many different ways to access the data in Pandas, and that's why it makes Pandas very powerful. Data frame is basically a collection of series. So if I check the type of df.date, which is this we are just looking at, it's just going to give us that this is a Pandas series. Or if I check one of the rows, it's also going to be Pandas series. So if you get any column, all of those are going to be series. The interesting thing is here, if you get any rows, they're also going to be series. And you could rely on whatever property series has when you're working with one row or when you're working with one column. But when I check the type of df, it's going to tell me data frame. This is a series, as I said, and this is going to be also a series. So here, let us look at an example, a real dataset example. So the adult CSV data is basically a data from 1996. It's from a consensus income data set, and it has 48,000 rows, and it has 14 attributes. So it's a fairly large data set, and you will see that by using Pandas, you could be doing a lot of data manipulation at a rate that you cannot imagine of doing with Excel or other similar spreadsheet softwares. So let's go ahead and start working with this data set using Pandas. What you will do is you basically say read CSV. So whatever the data is there, you just read it, and the data is going to be available to you on Moodle. So as long as this data set or this file is in the same location as this Jupyter Notebook file, this code will run. So once you run this, it gets that CSV file and read it in an instant. So you will have your data here, all of it. But you can see there are some breaks here. So because the data has, like I said, more than 30,000, it has 32,000 rows, there are breaks. So it shows from 0 to 4, and then there is that break here. And then also in the columns, you will see that because, oh no, all of the columns are shown here. So that's good. All of the columns are shown here. So a few useful functions. One of the things that we might want to use a lot of times, sort of like check that, you know, the data, our data is here, but we don't want to look at everything. So we use df.head that shows only the first 5 rows of our data frame. So only the first 5 rows. I could be passing a number to this function and specify what numbers of rows I want to be seeing. And if I pass 2, I will only be seeing 2. Tail sort of does the same thing, but from the bottom of the data set. So it sort of shows us the last 5 rows of data. I could be also changing numbers here, and I will be only getting, like, you know, 2, 1, or whatever numbers I want. So one of the things that as you start becoming more and more comfortable working with data, different data set, is you have to take your time getting to know a new data set. It's very important that you know every detail of your data, what type of attributes they have, what is the median, what is the average. You want to, like, sort of like go through this process of getting to know your data. And we here in this video, we model a little bit of that for this data set. So one of the things that you want to right off the bat use is the function describe. The function describe basically gives you all of the statistical summary parameters, statistical summaries that you could be getting from your numerical attributes. So you can see only the numerical attributes are shown here, and you get the count, you get the mean, standard deviation, minimum, maximum, and the other quarters of your data. And pay attention, this was done by just typing 2 words, and it's just done for you. You can look at your data, you can sort of like start getting a sense of what type of data you have here. So for practice, I want you to start watching this video and think about what type of numerical attributes these attributes are. So we had 2 numerical attributes. We have interval scale attribute and ratio scale attribute. Stop the video and think about what type of numerical attributes these are, and then continue watching. So age here is a number that could be from 18 to 90, as we will see. So since this is an adult data, because of that, there is no an inherent 0 in our population about age. That's why it's an interval scale attribute. If final weight is basically is the number of people each row in this data set represent. So when we say 77,516, basically from all of the population of 1996 in the US, this row represents 77,516 people. And since this could be anywhere from 0 to other numbers, this is going to be a ratio scale attribute. And then we have education number. Education number could be from 1 to 16. And as we can see that there is no minimum of 0 here, this also can be counted as interval scale attribute. And then we have capital gain, capital loss, and both of them we can see they have 0 and they go to a number, go all the way up to a number. These are ratio scale attribute. And then we have hours per week, how many hours per week they are working. And again, this could be from 0 to 99 hours a week, as we can see here, and therefore we can assume this as ratio scale attribute. And the difference between ratio scale attribute and interval scale attribute is for you to understand what is that measurement that's done. So you want to have a sense of the type of attributes that you're working with. So we sort of got our time getting to know the numerical attributes. But how about the categorical attributes? So the way you want to go about knowing categorical attributes is by knowing the possible values that each of them have. For example, what are the possible values of education? What are the possible values of work class? So to go about that, you use a very useful function, unique. So basically, these are all of my categorical attributes. I do a loop. I go through this list one by one, and each time I calculate what are the unique values of each of these columns. So once I run this, now I get a unique values of each of these columns. So for work class, I have state government, self-employed, not INC, private, federal government, local government. I do have some missing values. So this is a sign for missing values, and so on and so forth. So by looking at these possible values, I can know what are those. I can start getting to know these attributes. Another very useful function I could be using here is, instead of using unique, I could be sort of asking to see the frequency of each of these possibilities for each column. So once I run this, now it tells me for work class, most people in most rows are private, and then self-employed, nothing, INC, and so on and so forth. So for education, high school graduate, some college, bachelor's, master's, and so on and so forth. These are the most frequent possibilities, and then so on and so forth. So this is another good example for you, good practice for you to think about what type of categorical attributes each of these are. So we know that we have two types of categorical attributes. We have nominal and ordinal. And stop this video and think about each of these categorical attributes and tell me what these attributes are, what types these attributes are. Okay, so let's go over them very quickly and talk about what they are. Work class is nominal. Education is ordinal. Marital status, nominal. Occupation, nominal. Relationship, nominal. Race, nominal. Sex, nominal. Native country, nominal. Income, nominal. You could think of it as ordinal. There is an order, but since it's binary, it doesn't really matter. So it's nominal, I would say. So let's continue. A couple of other functions that are very useful in Pandas. One of them is sorting. Pandas allows you to sort by each of these columns or even the indices. So I could be sorting values, sort values based on age. So once I do this, now it sorts my whole data frame based on age. I could also be saying if I want it to be ascending or not. So the default is going to show ascending. So if you don't want it ascending, you say ascending false. Now it does it descendingly for you. You could, so now I have on a new data frame, which I call it sorted df. But I also could sort of sort it back to the original, order by saying sort index, and I'll get my sorted data frame, which was in the original order of the data. There are a lot of functions you could be using in Pandas. You could be calculating sum, mean, max, minimum, variance, mode, median, standard deviation, but just calling df dot, all of them. df dot mean, it gives you the mean of all of your numerical attributes. So if I uncomment any of these, it basically is going to calculate the that operation for all of the numerical attributes of that data frame. But if I wanted a specific one of them, so for example here I want the hours per week, I have to specify that, or sort of like, capture that series and then use that series function, and it does that for me. So let's see another example. Let's calculate the median of age. The median of age is 37. So here we have an example. We want to compare the average capital gain of individuals younger than 25 with individuals older than 35. So here, for this calculation, we are going to go back to that simple, powerful techniques, programming techniques, Boolean masking. So we create two Boolean masks, Boolean mask for younger than 25, Boolean mask for older than 35, and then we calculate the capital gain for those data frames. So do you see, when I do the Boolean mask, I'm only keeping those data of people who are younger than 25 or people who are older than 35. So once I run this, now I see the average for younger than 25 is 172, and the average for older than 25 is 1,618, and there is a significant difference between these two values, as one would expect.